dictionaries are great things introduced in 2016 that are basically keyword value pairs. You know, a dictionary is something you look up a word and find the definition for that word. Dictionary here is kind of exactly the same thing. There's a keyword and a value, and that keyword might be acquisition hour, and the value is the actual hour that image was acquired. And I can use these dictionaries to start to do very clever things like, you know, if I want to do generate shading, a new operator for 2016, generate shading. It's a little bit like relief, but relief is just a visual representation of sun angle shading of a DEM. Generate shading literally takes a date and time and calculates the incoming solar radiation in watts per whatever it is, square meter per, you know, whatever value at every pixel. To do that, it does need a date and time. So I built this little model that takes in a DEM, and I want to shade that DEM so that it matches an input satellite image that I have. And that satellite image obviously has shading inherent in it as well, based on the position of the sun when it was acquired. So I wanted to pair those up. So I basically used the metadata port on raster input to go ahead and create a dictionary of all the metadata from that raster input, and then pick, using the dictionary item picker, 6 of those keyword value fields, basically the ones that give me the acquisition date and time. I then use a lot of cat operations to construct that into a string that, again, I can use that from string conversion, or in this case it is just from string. I convert the string to a date time data type that can be fed into the generate shading operator. So very powerful dictionary item capability. So here's another one that basically looks up parameters based on an input sensor name that you give it. Here's one. Actually, this is an important one to just mention. A lot of people have been asking about, well, I want to do reflectance conversion for Landsat 8 data, top of atmosphere reflectance conversion from DN values. And really, to do that, you have to go into the metadata that's delivered with the image, find various values on scaling multipliers and additive values that are in the header, and apply those to the input data using particular formulae. And in the past, you basically had to do that manually. You had to open the metadata text file up in a text editor, find the relevant parameter, write it down on a piece of paper, find the other 13 parameters that you needed, write those down, then go run your model, type all those parameters in. You know, it's a pain in the backside. Here, new operator, or actually this is showing the Python script operator. So here I have Python installed. I've written, I must give credit where credit's due. John Fisher wrote a Python script that basically takes Landsat metadata text files and parses them and creates a dictionary output based on that Python script. So this takes a file input that is the metadata file, parses it using Python, and creates a dictionary. Then my dictionary item then reads the keywords out of that dictionary that I'm interested in and feeds them out into tables. So when I construct my Landsat 8 top of atmosphere adjustment model, I do exactly that. I strip out those modifiers into 2 tables and then basically apply the formula automatically. So I no longer have to go and manually look at the header. I construct a dictionary from that header and pull values from that dictionary that are the parameters I need, so it's all automatically done for me.